Today's lesson is known as the second fundamental theorem of calculus. For this lesson, we're going to work backward. We're going to start with an example and try to figure out what the second fundamental theorem of calculus is. So they want us to find the derivative of f. So if you take the derivative of one side of the equation, you have to do to the other side. So we have f prime of x is equal to derivative of integral of 5 to x squared of 3t to the second power plus 5 dt. Okay, the next step will be taking the integral. So we have d over dx. Integral of 3t squared plus 5 is t to the third power plus 5t from x squared to 5, which is equal to derivative of x to the sixth power plus 5 x to the second power minus 125 plus 25. And if you take the derivative, just keep in mind this last term will become 0 because regardless of what this number is, the derivative of a number is 0. So the derivative of x to the sixth power is 6 to the x to the fifth plus 10x, and this will equal to f prime of x. If you simplify this a little bit more, you could factor out 2x, 3x to the fourth plus 5. So if you look at the answer, your f prime of x, which is 2x times 3x to the fourth plus 5, is very similar to our original function, 3t squared plus 5. It seems like that t squared was replaced with x squared, because if you substitute x squared into t, you'll get x squared to the second power, which is known as 3x to the fourth. And that 2x is your derivative of x squared. So here is the equation of the second fundamental theorem of calculus. Second fundamental theorem of calculus can be applied if you're taking the derivative of a definite integral, where your lower limit is a constant and upper limit is a function, resulting in a composite function of g of an interval function times the derivative of your upper function. So let's look at the next example. Once again, find the derivative of f of x, where your f of x is the definite integral. So it seems like the lower limit of the definite integral is a constant, upper limit is the function. So we could apply the second fundamental theorem of calculus since you're taking the derivative of a definite integral that satisfies that condition. So if you apply the second fundamental theorem of calculus, you're going to get derivative is equal to composite function of 2x going into this function, which is cosine of 2x over 1 plus sine of 2x multiplied by the derivative of upper limit. In this case, the derivative of 2x, which be the answer is 2. So your answer will come out to be 2 times cosine of 2x all over 1 plus sine of 2x. Okay, so let's look at the last example. Now you have integral of negative x to positive 6x of 5n plus 7 dn. So this time you're still taking the derivative of a definite integral, but as you can see, the lower limit is not your constant. So in order to apply the second fundamental theorem of calculus, we have to change the definite integral so we have a lower limit as a constant. So we could rewrite the definite integral, so your f of x as integral of negative x to some kind of constant, let's call that a, 5n plus 7 dn plus integral of a to 6n of 5n plus 7 dn. Because the intervals are negative x to 6x, we know there's going to be some kind of constant in between. That's why we just call that constant a. Again, because we really don't care what the constant is. If you look at the first part of the integral, we still have our upper limit to be the constant. So we're going to rewrite that once again as negative integral of a to negative x, 5m plus 7 dn plus integral of a 6x 5n plus 7 dn. And now both of this integral is ready to use a second fundamental theorem of calculus. So our f prime will equal to negative 5x plus 7, because you're substituting negative x into the n, times the derivative of negative x, which happened to be negative 1 in this case, plus 30x plus 7 times the derivative of 6x, in this case is 6, will be our f prime of x. Now, if you simplify these equations, your final answer will come out to be f prime of x will equal to 175x plus 49. So going over what second fundamental theorem of calculus was, once again, is when you're taking the derivative of a definite integral. Just keep in mind that the lower bound must equal to constant and upper bound must equal to function.